Hello, I'm Ian. I'm going to be showing you how to use sensors to determine how far to move. First, you're going to need a move block of some sort. You can use the move tank or move steering for this. Then, once you have that block placed, you change the on for rotations to just plain on. And for this, we're going to show how to turn with the sensor. So we're using the tank drive, so we're going to use one at -50, one at +50. Then to have your sensor, you do not use one of these sensor blocks. These sensor blocks just take a reading of it and then output that to something else. You have to use the weight block here, and you place that after that. Then you change where it has time to whatever sensor you want to use, and it has the whole list here. It defaults to time. We're going to start with the light reflection, not color. So to do that, you go to color sensor, compare, then reflected light intensity, or ambient light intensity,
No.
or reflected, sorry. I messed up already. Oh well. Then after you have your weight sensor, I'll tell you what to do with this after we place this, but in order to stop it, you need to have another of the same move block. So since we used move tank, we'll take another move tank, put that after the weight block, and turn it off, and have it set to brake so that it does not coast from where you want it to be. Now, on the light sensor block, on the reflected light intensity, you can tell whether it's equal to, not equal to, greater than, equal to, less than or equal to for it. So we're going to say greater than for this, and then for here you'll change what it needs to be greater than, so we'll just leave it at 50. This extra part here is if you want to take the data value and put it into something else with this wire here. We're not going to talk about that in this video. And then a new thing for the EV programming and robots is you can actually tell where the robot is when you're running the program if you click run. So here we're going to click run, and if you look at the top of the bar here, there is this kind of hashed line that's scrolling across. That is just saying that it's currently sitting on this block, so you know where it is running while it's on the table or whatnot. And then once we have a white table here that we set on, so once the light sensor saw it was brighter than 50, which is white, it was able to, it exited. Then for the color, to compare color, you use color sensor compare color, and you can select what colors you want it to check for. So you can have it check for if it's blue, yellow, or red. So if your robot's running along the FLL table and it goes over a blue spot, then it will stop in this program. You can have all of these selected, or you can even have no color selected. The last color here is brown. That is just there in case if it goes through and says, okay, it's not black, it's not blue, it's not green, it's not yellow, it's not red, it's not white, so it must be brown then. If it is a color, then, and it's not all of those, then it has to be brown, is the way this is working. And that's pretty much it for using the light sensor.
Hello, I'm Colleen. We're going over touch and ultrasonic sensors. We change it right here. We're going to touch, and we're comparing the state at which it's at. We can either have released, pressed, or bumped. If we go bumped, it will say it's the robot's going to move until it bumps the wall or whatever it's bumping against, and then the motor stops. Okay, it can also be changed to pressed or released. It also all have the same effects. Alright, now we go down to ultrasonic sensors. We can compare the distance with centimeters. We can either be not equal to, greater than, or equal to, and so on and so forth. If we want it to be equal to 50, the motors would go until 50 centimeters away from a wall and then stop. We can do the same pretty much with inches, which it wouldn't be 50. It would be more like 4. So it will go until it's 4 inches from a wall and then stop. Alright.
Hello, I'm Philip, and I'll be talking to you about how to use the gyro. The primary function for the gyro that you'll be using it for will be turning. So for this, we will use a 0 turn. So we'll change this and go to our weight. We'll go to the gyro sensor, and we'll go, instead of a compare like most of the other sensors that we've been talking about, we'll go to a change in angle. And this will be the same. It will be either an increase, a decrease, or in any direction. We'll go with any. And we'll just say we'll try to do a 90-degree turn. Before you actually use the gyro or use the program, gyros vary and have error. So before you use it, you will have to reset it. You will go to Sensors, and you will find the gyro. Put it in front of your move. And then you will come down here and hit reset. This will make sure that when you start, your gyro is at 0 and not at a different angle, because that will affect your turn. Now when you run this program, be sure it will not always be 90-degree turn. Okay, if I run it, if you see here, it shows that the robot actually turned negative 111 degrees. That is over 90. So what you variables that affect turning with a gyro, it takes time for the signal to be sent out, so 90 degrees will usually not work. Width also affects it, so you'll have to experiment to find 90. So for here, we've already done it, and we found 70 works. So if we run it now, it has negative 91, which is almost 90, which works. It has a plus or minus 3-degree variance for the robot we have. Make sure for each time you make a turn with the gyro, what you change is the angle you're looking for and not the power that the motors are using. If you change the power, it will be different than if you change the angle. So for every turn you want to do, you want to pick a power and stick with it, and then change the angle. Experiment with the angle, and you'll be able to hit any turn that you would like or need. And that's all for gyros.